You think that's broken? Look at that. You can see right through it. Can you see that? You think that one went bad? It goes all the way through. Let me get my screwdriver here. There's a hole all the way through. Hello, this is the Lightning Stalker. What I have today is some electronic components that have undergone what is referred to and what is known as a catastrophic failure. Now, if you're not familiar with the term catastrophic failure other than from viral videos and memes, the definition is a sudden and complete failure from which there is no recovery, at least no direct, immediate recovery. For instance, like an error on the computer that can be cleared by rebooting is not considered a catastrophic failure, okay? Now, in electronics, that would mean that your component, such as a transistor like this, and this is what is known as the isotop package. Now, these are an industrial power package, if you're not familiar with them. And they're higher power, usually, than a standard TO package transistor, but not quite as high as some of the modules that they make. But they also have these screw terminals, too. And so they're a step above a regular transistor, but not quite to the point of a full-blown power module. But anyway, in terms of catastrophic failure, at least by the generally accepted definition, which I was kind of unable to get online, at least in a quick and clean Google search, is that would be when your component fails, and in particular when your component fails in a way that the case of the component ruptures or smokes, or you might see some sparks in some cases. Now, I thought it was good to show you this because this is a case where a catastrophic failure did occur, and I would say it's quite spectacular in this case. So what happened, what we had here was, this is part of a full bridge. There's another hole. This is on an aluminum heat sink, and we had a whole another heat sink full of devices just like this one, identical. And between the two of them, they form a full bridge. And what a full bridge is where you have four legs that control a single output device, such as a motor coil or something where you need an AC signal that completely reverses direction. And they're commonly used in high power applications such as this one. I believe this was a battery charger or a very early inverter welder, just because of the fact that these transistors are all bipolar transistors. They're regular bipolar. This is a 30 amp bipolar transistor, very powerful as far as bipolar transistors go. They don't get much more than that. So in total here, on this, just on this one heatsink, we have 10 large high-power bipolar transistors. These two up here, but these two up here are the base drive for the other four, and the other four over here. And then there's two diodes. Now these look the same, but that's just a superficial resemblance. These are a completely different device. So these are dual diodes. So there's two diodes in here and two in here. And so what happened was some transient or something, some insanely wicked transient came across, and out of all 10 of these devices, and I'm sure the other heatsink that came out of this machine is the same, out of those 10 on this one heatsink, only one still works. Okay? So this was a total wipe, basically. And I don't know what miracle saved that one, but it's amazing that one of them did survive. And I want you to see this carnage in here. See this little area here where it's kind of discolored on this copper plate? This is the common plate that the collectors all shared. See that little discolored area? The corners kind of looks like it got oil spilled on it or something. Well, that's not oil. That's from heat. And if you look here, there's a little circular area right there. So what actually happened was, and it's going to be kind of hard to get the camera in there to get a good look at it, but if you can see that little screw head there, that's the screw, one of the two screws that holds down this transistor. What actually happened was an arc formed between this metal plate and the screw head on that screw. And it's kind of hard to see, but there are no longer flats inside that screw. It's just completely rounded on the top. It melted. Okay, so there's a huge electrical arc there. You know, about, I would say approximately 10 to 15 millimeters in length. That's about a 1/4 inch. So you can see the brown crap in here that as that arced, the smoke from it and everything, and all this charred remains of this device. You can just pick at it. There's basically nothing left of this thing. And I can't even get this screw out because this goes into a little nut down there, and the nut is completely rounded out because that plastic is just gone. It's ash. So that's what happened to this one. But believe it or not, this is actually not probably the worst transistor, even though it's, you know, the arc formed here, but it hit the screw. So it wasn't actually inside the transistor. And you can see similar green, that's from copper soot here from when this exploded. And I'm sure it exploded. I'm sure you could hear it. If anyone was there when this happened, I'm sure they heard it. I don't know if this got struck by lightning or what, but anyway, it's pretty bad. So here's more of the bad ones. There's just a handful. There's just, you know, handfuls of these things that failed. One of the failure modes I mostly noticed on these, it's really hard to see, but they're cracked. So inside there, something happened that released like gas or something, or it's just I don't know if you can see it on this one, but it cracked the plastic. It's like an epoxy type plastic resin. See it? See that crack there? And it was about ready to probably blow the whole top off, but it was protected because they were all held in so firmly by these metal pieces and stuff. So I'd say most, you know, probably all of them failed like that. And so something in there was actually arcing inside, probably when a wire, like a bond wire, exploded. And I have an extreme example. Now here's what I was wanting to show you. Look at that. You think that's broken? Look at that. You can see right through it. Can you see that? You think that one went bad? Look at the bottom. See? It goes all the way through. Let me get my screwdriver here. There's a hole all the way through. I've never seen that before. I've seen where it comes close, but that's a metal plate on the bottom that it just tore right through. And I think that's the one that was mounted here. You can see, yeah, there's like a little spike or welded stuff here. See that? That just came off. That's metal that was deposited on this heatsink. I've never seen one that bad, but I mean, I can understand because we're dealing with pretty high currents and stuff in these things. You know, this is probably, I assume it was for charging forklift batteries. And if you've ever seen those things, they're 75 volts and they're about the size of a suitcase. So they're pretty large. And the wires coming off of them are about as thick as my thumb. So you can imagine that if something goes wrong, it can go really wrong. So, but anyway, I did manage to get one, and I'm thinking maybe I can do something with it. I don't know, but they have pretty crazy requirements as far as base drive. That's why they don't really use these in high power applications, because it gets to the point where the base current has to be so high because the gain will drop. As the collector current goes up, the gain goes down. And to the point where at 30 amps, you're sitting at like 8 amps into the gate. So it's like really inefficient, like in terms of like switching. Unless you can somehow like do a Darlington or a Trilington where it's actually switching through the load. But yeah, I mean, that just gives you an idea. So that's catastrophic failure in power electronics. So I hope everyone enjoyed the video. Thank you for watching. Don't forget to share the love. And have a nice day.